channel. My name is Opubo. In this channel, I present various ideas and designs of technologies, mostly from the Technology Bank of Enhanced Knowledge LLC. This presentation focuses on Biofuels Burn Power Supply technology, which at its core is no more than a transducer, meaning energy converter. With this power supply or technology, chemical energy gets converted into electrical energy. More specifically, moving from left to right, the biofuel is aerosolized, if liquid, as in the first picture, and then burned, as in the second picture, converting the chemical energy into heat or thermal energy. And the heat energy then extracted and converted into and made available, as in the third picture, as electrical energy or electricity. This concept is well understood and poses no risk to prospective users. The technology burns input biofuel, whether of liquid phase, bioethanol, biobutanol, biodiesel, or of the gas phase, biogas or biomethane, or some combination thereof with the output of electricity. And hence the technology is an electricity generator, but rightfully power supply in consideration of the compactness. The usefulness of the technology lies in the reality that the power output is sufficient to power the needs of a home, and that effectively the power supply can find deployment as portable backup power supply in single homes and as primary power supply for log cabins, houses that are off-grid, houses in locations remote from civilizations, and homes not in the areas of any regional power provider, and what have you. Digressing for a moment before we go much further. If you have not clicked the subscribe button at the bottom of this video and subscribed as yet to the channel, do please take a moment and click the subscribe button and subscribe to the channel. The subscribe status causes the system to have you informed of the next presentation the moment a new one is released. Returning to the technology presentation. The power supply is effectively of a single cylindrical design with base perforations and feed ports for the biofuel. On the body, about 2/3 of the height, the cylindrical form yields to a sleeve of fastener structured form with externally bounding hexagonal faces, with one of the hexagonal faces cut into a slot as a pocket for and housing an electrical panel, and two faces away similarly is cut into another face with a pocket for and housing a socket transmitting direct current being mated with an inverter that generates alternate current from the direct current, with one matching line being live and the other being the return. And yet again similarly, two faces away is another cut of a pocket for and housing an electronic controller device with wire bundles returning to the electrical panel. Although the power supply is provided preferably with electronic controller device mounted on its body with the hexagonal face slot for single homes, the controller device can be kept and used remotely from the power supply. Further, at about the top of the power supply, two bundles of wire extend out and are fed into the electrical panel at two extremes of the bottom panel wall, and in the middle of the power supply are of course two bundles connecting to the DC socket. The top of the cylinder narrows into a cone and bends away to vent the combustion gas. Two biofuel feed tanks are included for ease of use. Upon deployment, the biofuel input ports on the power supply are respectively connected to the biofuel feed tanks of bioalcohol and or tanks of biogas. The design of the interior of the power supply, of course, is proprietary and so is being omitted in the presentation. The direct current sockets are a unified laminar plugs as in the drawing in the photo, with the positive or live wire as one line and the negative or return on the other, in a sense offering a simple socket for the user. Ordinarily, a portable inverter is plugged into the DC socket, converting the current into AC of the locale, be it 110 volts, 120 volts, or 240 volts. Operationally, the user switches on the power switch on the electrical panel, and the pump starts pumping biofuel into the power supply. Shortly thereafter, the electrical energy is generated and circulates through the house. Although the output of a single power supply is sufficient to power the needs of a home, in those cases where such is not the case, even with the operating state of the power supply having been raised to the limit, there is the option to add additional power supplies, creating a bundling of as many power supplies as needed for the situation of consideration. The power supply performance is dependent on 4 primary variables, and as such, the controller design is also centered around those 4 primary variables, which are biofuel and airflow, and the others internally controlled parameters. Accordingly, the electronic controller device is designed to enable effective control of these variables. Designing to accommodate these variables result in the design specification of property select push buttons at the lower left side of the panel of the controller device, and next to those 4 directional buttons, the left pair being for up and down vertical selection, and the right pair being for moving left and right horizontal selections, a power switch, and 1 USB port. Then, of course, the controller device also has certain other unique features that enable the setting of the variable properties of the power supply. One obvious required component included is an LED, the large black square display screen, set at the black color to give very sharp contrast that shows the information of data related to the settings and measures of the power supply. In addition, the controller device has at its core a composite of a compact computer and a controller software, all integrated into the hardware as embedded systems. There is also a preloaded chemical and thermodynamic properties of the biofuels, including heats of reaction of verified decomposition, making it easy for a user to become informed of the output, projections, and such plan accordingly. Then, of course, all import power switch power up both the controller device proper and the power supply. At start of use, the power switch is turned on, and then the biofuel select buttons are used to set the biofuel selection. The LED screen informs on the selected biofuel or biofuels. The selection of a biofuel sets the controller embedded software computation algorithm to become loaded and ready to compute the energy projections the moment the flow rate is set, even if temporarily. The control valve for changing the flow rates of the inlet feed rate is controlled through the adjustments of the flow rate button of the property control push buttons. The button gets selected, and the 4-arrow button is selected to set up and down settings. The push buttons for arrow decrease, the bottom push for arrow decrease, and the top push button for flow rate increase. Selection of the flow rate buttons instantly displays on the LED free data, variable identity, in this case displaying the settings as shown in the viewing image. Biofuel, property, set value, and projection. When the flow rate set value is changed, the value of the projection will also change dynamically as the embedded output projection software computes a new value set or as held temporarily steady. Particularly notable is that a changing of the biofuel of choice will cause the projection algorithm to dynamically recompute the power output projection. The degree of combustion button informs on whether the biofuel input will be completely burned before being effluent or not. In that respect, the properties that are displayed are biofuel, property, set value, projection, airflow, and the degree of combustion, and effectively guides on the need to increase airflow to the end of effecting complete combustion. In the case of prevailing need for more airflow, then the airflow rate button is selected, and again the operational push buttons are used to increase or decrease the airflow as necessary. There is an overview button as well that gives snapshot display of all the performance status of the power supply at a given moment of time that the user wishes to learn of the state of the power supply performance. It's the status snapshot. This gives report on demand on, again, biofuel, property, set value, projection, airflow, combustion, and the additional variable preheating, which is an internally controlled and measured property. The user not satisfied with any of the operating data as shown may then adjust the data as preferred, keeping in mind that the system may override some settings if such settings seems to impair the performance of the efficiency of the power supply. Besides the control of the operations, there is also on the controller device a push button that informs with a progress bar displayed in the LED on the volume of biofuel left in each tank and the rate of consumption of the fuel. The display is offered in terms of percentage used and the number of hours left to empty as determined by extrapolation. This display is for the purposes of guiding informed decision on fuel management, including call for supplier for delivery of replenishment. There's also the USB port into which user may plug in to a laptop, which is used to download and upgrade the various embedded systems as well as perform general customer specific options. Although the presentation has focused on single power supply use or a limited number as a bundle, the option to bundle the power supply, of course, addresses the consideration that the power supply can also be deployed for commercial power production needs. Although for commercial application, the power supply is deployed as a module of a bank of several. Furthermore, the operations will have to be supported on continuous biofuel production processes without specifics of whether gas or liquid biofuel. Indeed, for such large-scale commercial deployments, the process would have to be significantly aided with reservoir of biofuel, biogas, or both, whether with production processes as already noted or large storage tanks of these biofuels. In addition, an integrated electronic controller system designed to manage all the components will be needed for smooth functionality. Significantly for commercial scale operations is the ease of the power supply even being retrofitted into a turbine for increased wattage, and hence can be deployed for even industrial power production for the needs of communities, municipalities, and industrial operations. Notably, for deployments for communities and municipalities, there is this potential added benefit of having the biofuel source be the mechanism for the disposal of domestic waste. This would be a win-win situation. Now then, as is obvious from the presentation, the electronic controller device is the main point of interaction between the user, consumer or process operator, and the power supply, except for occasional direct switches on the electrical panel of the power supply, making the use of this power supply extremely safe, whether in consumer use context or industrial operations context. Parties interested in getting custom fabricated power supply delivered may directly contact Enhanced Knowledge LLC online. You can be found on the internet. Thank you for watching this video, and I implore you to return to watch the next presentation. And if you like this video, then also please click the like button. And again, I thank you very much. I appreciate you.